So we can draw that rule for negative exponents from the previous page. Negative and we can begin with our rules right here. So a divided by b all to the power of a negative exponent becomes b over a power of a positive exponent, the same exponent there. We already remember our zero rule from earlier. We've worked on it a few times. Anything to the power of zero, let's use a here. A to the power of 0 equals 1. Not going to go over that again. If you're curious about it, I can explain it a little bit in more detail, but we did that in class. Now, if we use these exponent rules, we can evaluate our expressions down here. So 3 divided by 4 to the power of negative 2, that's a negative exponent. So what I'll do is I will flip my fraction, write it to a positive exponent, squared. And then I use our rule for fractions that we went over yesterday. 4 squared divided by 3, squared. Equals 16 divided by 9. And that's how we'll approach these problems. I'll do one more for you. Instead of my fraction being 1 divided by 2, I'm going to use 2 divided by 1. And my new exponent will be a positive 4. That's just a 2. We know 2 divided by 1 is just 2. Power of 4, which is 16. So I'll let you work out C on your own. If we work here for 2a, the difference is instead of working with just numbers, we're working with variables here, and we know how those work. So we can change our fraction, we can flip it, we can invert it there, and cube. Now we're working with a positive 3 in our exponent, leaving us with y cubed divided by x cubed. B, we have a couple rules happening at once. The first thing we're going to do is work with our negative exponent rule up here. So we'll flip the fraction, b squared over a to the power of 5 to the power of 2. All of that's to the power of 2. And we've seen questions like this before here, where our numerator becomes already was b squared, and that now gets squared again. Our denominator was a to the power of 5. Now that's squared again. We use our power of a power rule in our numerator, bringing us b to the power of 4. And the same thing in the denominator. We use power of a power, so we're multiplying our exponents, leaving us with a to the power of 10. I'll let you work out C here on your own. For 3, we are going to use the same rule here, but we will use it in a different way. So we can rewrite this 6 here as 6 divided by 1. Just as we did earlier, if you divide anything by 1, it is just itself. It's equal to itself, so we're allowed to do this. And that's all to the exponent negative 2. Well, this looks just like our questions in example 1, where we can flip our fraction, take our negative out of the exponent, and work as we have before, leaving us with 1 over 36. I'll let you use this same strategy here that I used for A. I'll let you use that for B and C. Here we have our zero exponents, just like we saw up here. Our rule for zero exponents, zero exponents. A rule for zero exponents is anything, absolutely anything to the power of 0 equals 1. So that means 7 to the power of 0 equals 1. That means 3 over 10 to the power of 0 equals 1. That means 2 to the power of 0 equals 1 times negative 3 to the power of 0, which equals 1. All of that equals 1. I'll let you solve 5 on your own. That one's a little more advanced, but we'll see if you can get through it because you're just using the same lessons that we've gone over in the past.